Hi, this is Ashish R. Bedekar and welcome to my podcast, The ARB Show. I'm thrilled to introduce today's guest, Manan. Manan is the founder and CEO of Silicofeller Quantum. He is a quantum computing entrepreneur, passionate about the subject and its potential to change the world. His background is electronics engineering from Vellore Institute of Technology. He is also an IBM certified Qiskit developer. He has a strong technical background and is passionate about building scalable quantum computing solutions. He has been involved in the development of quantum computing chips and superconducting quantum computing chips. He is a strong advocate and wants to make India as a leading hub for quantum computing research and development. He is a frequent speaker at various events and always keen to share his knowledge and experience with others. Over to you, Manan. Very excited to have you on the show. Do share your life journey, your vision for Silicofeller, and maybe talk about the top five trends you see in quantum computing. Over to you, Manan.
Thank you so much, Ashish, for the warm introduction, and I really appreciate you inviting me to this show. And so I'll just take the time out and tell everybody who's watching the what actually quantum computing is and how can it transform the world out there. So quantum computers are classically different from the computers that we are using today. So what quantum computers are basically the fundamental unit of computation changes, right? In classical computers we are using transistors, but when it comes to quantum computers we are using qubits, which are quantum bit. Now each quantum bit can be in a state of superposition of either 1 or 0 at the same time, and we are extracting this phenomena called quantum superposition and quantum entanglement to create such powerful machines that can revolutionize entire industries. So you pick any industry, be it healthcare, automotive, finance, is going to massively change with the advent of quantum computers. So just to give you a layman's perspective or an analogy, you can consider quantum computers as an LED and classical computers or the systems that we are using today as a light, as a candle. So that's an analogy that will help you understand the scale or the extent to which they are different in terms of fundamental building block of computation.
Wow, I mean that's a very elegant and a very powerful mental analogy, just to give the context of how advanced this technology would be once it matures compared to what we have right now. Excellent. So really keen to hear from you what you're doing at Silicofeller and what do you think are the top five trends which people should watch out for in quantum computing. Over to you, Manan.
So firstly, at Silicofeller, we are making sure that quantum computers can be democratized. People can get access to quantum computers. So we are trying to spread awareness about quantum computing, all the while developing and working on quantum chip designs. So that is what we are doing as of now. We also have a platform which is under development right now and not available to the users out there, which is making sure that the quantum computers that are available right now can be utilized to the full extent. So the problem with quantum computing right now is that there's too many players working on different technologies. So there's 6 or 7 different ways via which we can build a quantum system, and every single segment of that is being developed by companies. So there's no a unification of which particular platform to choose or which modality to choose. So that has actually hindered the development in the quantum hardware, even though it has been progressing very fast. But if we all could come together, it would surely be even more faster, and we could find the applications of quantum computing that are useful right now. So because of this divide, the quantum computers are still noisy, which means that whenever I'm putting in asking a solution to a particular problem, it's going to give me errors. And even though these errors are very low, but over a period of time these errors can accumulate, and then you have a massive computation gap in terms of the answer. So that's the big problem the industry is facing right now. And there are techniques to mitigate these noise and these errors in the quantum system, which is in advanced phase of research right now. So all in all, I think these are the trends that I see in terms of where quantum computing will be going in the future, where people are working together and making sure that these noise and quantum computers truly become useful in the future.
Right. So essentially, from a Silicofeller perspective, you're kind of creating a platform where you're abstracting or making the various methods of creation separate from the application. So it's a unified kind of a platform. Would that be correct in saying?
So the platform currently which we are working on is focused more into the computing side, where we are still finding out the applications which are useful to the customers. So at the end of the day, we have to provide value to the customers in the end, right? And providing that value means that there should be significant advantage in their exit from their existing approach. There should either be a advantage of time, where we are solving problems faster, or an advantage of cost, where we are solving problems cheaper than the existing algorithms or or the techniques that we're implying. So what is happening is that with our platform, when even though we're still using it, the amount of research that is going into finding these algorithms, it's huge, and figuring out the usefulness and practicality. So that is where most of our efforts have been in trying to make sure that we can find genuinely useful applications which solve the customer's problem.
Got it. So, customers for you would be some kind of hardware manufacturers where you would supply the chip and then they package it along with other hardware elements and then implement it in a specific application, similar to what happens in the existing server or the hardware market. Is that the same way you would look at the opportunity for you?
So in terms of hardware, we are still focused more on the design side of the processors. We are more into making sure that these systems can have logical qubits instead of just physical qubits, because there's to make a logical qubit you need lots and lots of physical qubits, and that is where the surface codes come into the picture. So now what we're trying to see is, can we make sure that this particular ratio can be minimized? Are there any active efforts being pursued by the researchers across the world that can help us identify these techniques that can essentially bring the fault tolerant era of quantum computing closer to reality? So
Got
that
it.
is being one approach. So it's very difficult to find those approaches, but yeah, actively we are still pursuing that in the company.
Got it.
And apart from that, coming to your next question regarding the customers, who are the most probable customers, it would either be a big company which is solving a problem using a supercomputer, and now they want to focus on solving that particular problem with a quantum computer. So it would always be hybrid with quantum and classical HPC systems. So
Got it.
that's the customers that have these infrastructures in place can connect to the quantum computers via the platform that we are developing.
Got it. So typically, we are talking about weather forecasting, advanced financial calculations, or trending, or maybe space telemetry and similar fields. Is that correct?
Exactly, yes, that's
Okay,
correct.
excellent. And how far are we from kind of early beta customers or early customer adoption? Maybe 2 years, 3 years.
No, no. So actually, we are seeing pilots. We have some pilots going on,
Very
which are
nice.
still, we're working on that currently. And once these pilots are completed, very much you'll be able to see some announcements also in the future. So we are working with leading tech companies, partners all across the globe, trying to make sure that this technology is something that is ultimately getting useful in a much shorter span of time rather than 3 years, 5 years down the line.
Fantastic, fantastic. And so that's exciting. So for the audience, this is great news. Essentially, it's not a science fiction project. It's already close to market reality, and the next coming months or years, we would see some news from Manan and his team. So it's really exciting about that. And as Manan eloquently mentioned, we are talking of a quantum, to use pun intended, improvement in the overall performance. So just like between a technology of candle and a technology of LED, there's a vast amount. So that's the kind of jump in technology performance what we can see. That's great. So coming to some of the trends which are in when you talk of quantum computing, one common question I'm sure lots of people would ask you is, what is the opportunity with AI, and how does quantum and AI coexist, and do they accelerate each other? How does it work?
Yes, that's a very interesting question. Like, as of now, there's the AI boom that is happening, and very soon this boom is going to happen in quantum. And what's it's gonna look like? So currently, you're seeing that artificial intelligence is a big threat in terms of the jobs, right? So I believe that if you look at the software engineers, right, and the programmers out there that we used to code, so that is going obsolete for now, right? There must be some higher level purpose that they will solve, particularly in terms of giving prompts or actively trying to debug, but that is also being done by AI right now. And very soon we'll see the white collar jobs, like the sales job even, right, or the HR jobs. Those will be the ones that will again be taken over by AI, right? Because you could essentially make a call to some person, and that can be done much better way and efficiently by let's say an AI agent that is trained on your data set, and it knows everything about your company, and it has that edge over the human who can possibly make an error, right? So it is not that advanced right now, but in the next 1 or 2 years we'll be able to see when the AGI comes that AI is essentially something that is an existent it might be an existential threat to the jobs out there and to humanity in general. But the as an optimistic myself, I would like to focus on the positives, right? What all things can it change, right? So obviously, if you look back in time, technology has always improved the lives of human beings, right? If you look at the medicine technology that has progressed so far, like when there was the eras of famine, so millions of people used to die, but that does not happen with the advent of technology. You see how COVID-19 happened, and we were able to make drugs more faster and vaccinate a lot of people out there. So that was essentially played uh, the role was played by technology over there. So now with the same thing, I believe that with technology everything is going to become much better. There might be possibilities of extending human lives. There might be possibilities of trying to possibilities that we haven't even thought of yet coming true with the help of AI. And when it is combined with quantum computing, so the missing pieces of AI, like consciousness, like emotions, all these can be combined with the help of quantum computers, because of the fact that quantum can process vast amount of computational spaces at one time. So what that essentially means is all the possible scenarios that could essentially happen could be processed in one single go, and that gives it a ability that people cannot comprehend as of now. So that is very much important. And with the current place where quantum is currently in the present moment, and where AI is presently, so the only thing that we could do with AI and quantum coming together is trying to make better algorithms or make better error correction models, so that we can bring quantum fault tolerant quantum computing closer to reality. So that's where I believe that AI models trained specifically on a user's data set, which is for quantum computing, can essentially progress that much faster. And it's not just something that we are doing internally. A lot of companies around the globe are also doing this, using AI to mitigate the errors in quantum, using AI to find more algorithms in quantum computing. So that's the area that we're already working on. And I believe that as the AI begins to become better and better, so there's going to be a point where there is AGI coming in, and then essentially the power of a human mind is limited, right? And the AGI is becoming more and more powerful. So I think that that would mean that an AI would be much better a user or a operator for a quantum computer, right? So they could find more solutions. They could find it much better way than humans can, and that essentially means that it could be might possibly be the last invention of our times. So after that, we can just see that AI and quantum developing stuff for us, like we see in the movies. So that's very much sci-fi, but we'll see that it's all being developed by them. So it might just be our last invention.
Wow, that is a very scary prospect. I hope human mind is much more capable than that, because it should not, it kind of reminds me of the Terminator series, wherein you have singularity and then that's the end of humanity. So I hope we don't go that route. Just coming back to the topic of AI. So one of the main criticisms of AI is the kind of energy that AI just guzzles, right? And there were some calculations which say that every small AI query or every small AI prompt which you use, it kind of consumes so many gallons of fresh water and electricity, things like that. So with quantum computing in the mix, do you see that the energy requirements of for AI actually get reduced because you're able to compute much more in the same kind of amount of time, or it's not linked at all?
Yeah, well, that's I believe that is speculative, but I think that with the quantum chips, we can, if we can have a way to essentially, so right now they're in such large rooms, quantum computers. If there's essentially a way to compress that technology, like earlier the computers were so big machines like mainframes, and you had those large machines, and now a computer is still inside your pocket, right? A phone is a computer essentially. It's everything has been compressed to small chips, and the power consumption is becoming lesser and lesser. So obviously, if we can do that, it would essentially mean that we can then even if we combine all the data centers on the earth, right, that would be equivalent to a 50 or a 60 qubit quantum computer, a fault tolerant quantum computer, because the amount of memory is required is doubles with every single qubit. So that makes it impossible to even if you combine all the classical computers to reach that same level of computation. So we could do that in general. We can and if we start running those models, AI models on quantum computers, we find out a way to do that. So I think it might be very much possible to use less amount of energy and save a lot of energy.
Yeah, but interesting. Many of the things which seem science fiction, become reality very fast. So even though I'm sure many of the audience would be shocked when they hear about quantum computing and what it can do, but I'm sure in the next 5 years or so, we will find out. The another contrarian view to this is that many times all of us in technology are in our own bubble, right? So the actual mainstream adoption would still take time, right? And there was a very interesting
Yes.
infographic shared some time back, where which said that only less than 1% of actual potential users are actually paying for premium AI. So anyway, so those are trends. We'll see how that goes. Coming back to some current trends, any specific trends which you could like to share with the audience when it comes to quantum computing? So it could be the kind of companies which are kind of getting into this area. You can talk about what are the kind of new applications which initial application success which you have seen from other companies or elsewhere, or it could be some potential roadblocks for quantum computing or anything. So looking forward to hear your views on the current trends.
Yeah, so the current trends that I see in the market are, obviously Psi Quantum. They're working on a million qubit quantum system, so they are essentially, the front runners, in my opinion. If they are able to do that, it's going to be such a great thing. And then secondly, companies like Microsoft, their Majorana qubit, which has come up recently, if they're able to do that and scale it towards millions of qubits, I think they can be a really really interesting watch. Plus there's some interesting research being done by Google, where they've developed discrete time crystals which essentially oscillate over a period of time, which is something mind blowing. And that is essentially what I believe is, the areas, the companies to watch out for: Google, Microsoft, IBM, of course, and Psi Quantum. And coming to the application, so I think as a entrepreneur, and as somebody who prefers to see this technology being used for the good in the world, we need to stop just thinking about the use cases that we're all working on in terms of optimization, logistics, right? And we need to think much how we can use this technology for the betterment of mankind and solve problems like pollution, right? Air pollution, water pollution, and solve problems like poverty, right? Corruption. All these are the areas which we can use this technology and find problems to the solutions much more efficiently, right? So these are the real world problems. If we can solve global warming, so these are the kind of issues that we all need to focus on, and trying to see how we can use this technology for the betterment of humanity and mankind, so that we're not just focusing on those niche areas which we are focusing now.
Fantastic. I think that gives a very good perspective, because, as they say, if technology is democratized and technology for good, then it's much more sustainable and not a flash in the pan. And we have seen in the technology a lot, right? There are technology trends which come, they are hyped up and they have a very short life because they don't really impact a lot of areas the way it was expected. And yeah, so with quantum computing, and we are able to solve things like pollution, things like sound pollution, or general quality of life, cure for cancer, one of the biggest challenge out there. So
Yes,
those are the
exactly.
things which I'm sure will find some great perspective. So that's about the current situation, and I'm sure the quantum computing is extremely fast paced kind of a field. But any predictions for the next 1 year? Because even in technology nowadays, 1 year seems a very long period. So any predictions for the next 1 year, the way you see uh, uh, quantum computing evolve? And I'm sure in the next 1 year also we'll have a good use cases and success stories from your company as well.
Yeah, that's looking ahead a year. Maybe I believe that this, I hope there's some revolutionary application or a use case that does come out. I hope that happens. But realistically, if we're thinking, we can advance this technology and try to decrease the costs, maybe, or try to find a novel way to solve a particular problem. That could be one thing that might happen. And apart from that, there's very good stocks that are coming up in the quantum computing space. So there's inflection that has recently been announced on the stock market. They've been listed on the stock market. So people can just buy these stocks now from anywhere in the world, and I believe that you should hold on to them. Not think about 1 year, 2 year, think about 5 years, and just hold on to them, and you may in the process make money out of it. So that would be my advice, not to think short term 1 year. Think about 3 years, 4 years, 5 years down the line. And that's just what I believe will happen in quantum. But coming back to AI, which is the current trend, realistically in the next 1 year we might see the stocks of large companies going down, which has happened recently in the case of IBM, when Anthropic announced their new COBOL capabilities. So consulting companies, because all of this can be done with AI now. So this might be the right time to short some of those stocks. I don't know if I was there, I would do that. But yeah, that's where essentially the technology is heading right now, where everything is being automated by AI. So obviously AI and quantum is going to be something very interesting, and we might see something happening in that particular area in the next 1 year.
Okay, again, a disclosure, the show does not subscribe or does not give any financial advice or any pitches. So, that was a personal comment by Manan, just putting it out there.
Yeah, definitely. That's my personal opinion.
Yeah, excellent. Thanks, Manan. This gives a great perspective, and thank you, dear listeners, for tuning in. Do subscribe, share, and like this podcast. Consider giving it a 5-star rating if you have liked the content. Bye for now. Talk to you soon. Thanks, Manan.